Okay, I think we're now live streaming on YouTube. Hello, everyone. Welcome to Kyverno Office Hour. Here we have Nirmata folks hosting this office hour. And this is our seventh episode, which we're going to talk about the Kyverno extension service that executes the AWS Signer plugin to verify image signatures, attestations, and beyond. Okay, to get started on this, extension introduction, I would like, to first briefly talk about what is this plugin, what is AWS Signer and the Notation plugin, how people can use this Notation COI to sign your container images, and then we'll look at how this Kyverno extension works. We'll, dive deeper into the workflow of how the plugin service work, and then Vishal is going to have a live demo on all the supported features, right? So to give you a little bit context on this, this is the Kyverno extension service that executes the AWS Signer plugin for notation that you can use to verify image signatures as well as attestations, right? For those folks who are not familiar with this AWS Signer, this AWS Signer is a fully managed code signing service that you can use to ensure the trust and integrity of your code. And by using this AWS Signer, you can validate your code against digital signatures to confirm that your code has come from a trusted publisher. And Notary, as you all know, this is a CNCF project that can sign and verify images. And the notation is a CLI, the command line interface, that implements the Notary, right? So you can use the CLI to sign and verify your container images. And the AWS Signer is integrated with the Notation CLI. And this integration gives you the native support for signing and verifying container images that is stored in the registry like ECR from AWS, right? So if you want to know more, get to know more about this AWS Signer plugin for notation, highly recommend you to browse through this blog post, where it has every step captured from how you install the Notation CLI to add the AWS Signer plugin to the notation, to how you can use it to sign the ECR image. For example, let me see here, you use this notation sign command, and there you give the plugin name, which we point to the Amazon AWS Signer notation plugin. And you can use this command to sign your ECR images. And once that is signed, you can, you can inspect your image as listed here. Under the signed attributes, you have this AWS Signer plugin listed here, which indicates this signature is attached and signed by the Signer plugin. And once that is the image is signed, you can use the notation plugin with the configured trust policy. By the way, the trust policy is something available in the notation where you can specify the trust identities and the scope of your registry or the image that you want to verify, and then eventually verify your container image using the configured trust policy, where you can see it is verified here, right? So with the notation verify and the imported trust policy, you'll be able to verify the image that is signed by the Signer, AWS Signer plugin. Right, so highly recommended you to look at the blog post, understand how the AWS Signer plugin works, how to use that to sign the image. And instead of using the notation verify command to verify the image that is signed by the notation plugin, here we're introducing this Kyverno extension service that leverages the AWS Signer plugin. We have the plugin binary embedded in this Kyverno extension service. And we're going to use that to verify the notary format signatures and attestations, right? So here's the high-level flow of how this extension service works, right? So as you all know, Kyverno, when you install Kyverno in your cluster, it runs as an admission controller that receives the admission requests that are forwarded by the API server, executes all the configured policy. It has the engine embedded in the Kyverno controller, executes the policy and return the result back to the API server, and make the decision whether your incoming request should be blocked, should be mutated, or should be rejected, right? So in addition to the Kyverno deployment here, we want to use the this AWS Signer plugin to verify the image, right? So you have to install this additional service, this Kyverno extension, or we can call it Nirmata extension, that has the AWS Signer plugin binary embedded. And whenever Kyverno receives the admission request, it'll forward all the images data to the Nirmata extension service, and the extension will talk to the ECR registry, pull all the image data payload, and then use the plugin to verify your container images, whether it's for signature verification or the attestations verification, right? And since it has all the payload, all the information of your images, it can also do the image tag mutation, right? Typically using the image tag is not the best practice. Instead, you want to mutate the image tag with the image digest to make sure your workload is secured, right? So this is the high-level architecture of this, how this Kyverno extension service work. And to look at some of the highlighted features that we support in this extension, obviously you have this image signature verification ability where you configure the trust policy and trust store that'll be leveraged by the notation. And then it'll use the configured trust identity to verify the given image. And here we briefly talk about the attestation verification. If you look at this policy snippet, by the way, this is the Kyverno policy where you sense this attestations information of what you want to verify. And if you look at this policy snippet, we have two conditions here, right? For any of your container image, here we're using the wildcard to match all of your incoming container images. And the first filter or the condition here, we want to check with the type SBOM, cyclone-DX. We want to make sure your license version has to be 3.17. And the second condition here for the type application, serif JSON, we want to make sure your license does not have the JPL license, right? And the second rule here says for this particular image comes from ECR registry Kyverno demo with all versions, we want to make sure your license does not have any JPL license either, right? So here's the example of and how you can verify the attestations. And in addition to the image verification as well as the image signature verification, as I mentioned earlier, you can also mutate the image tag with the digest. Since you want to ensure your image integrity and prevent tampering, the best practice is to always use the image digest instead of using the tag when you deploy your application. And here, since Kyverno forwards all the images, payload, or data to the extension service, this extension will pull from the ECR registry, resolve the image tag to the digest, and then send back this mutation patches back to Kyverno where it has the image reference as well as the digest and the patches at which path you want to mutate the image, right? So here is the mutate rule where you can mutate the container image to use the digest instead of the original image tag, right? So we'll see those demos in the live cluster just in short. Before that, let's look at some of the additional features that we have, right? With this extension service, we enable this caching mechanism where you can configure it's a TTL-based cache where you can configure the TTL duration in seconds. And of course, you can configure the max size of your cache entries, and it is enabled by default, right? So this cache, it can be used to prevent repeated lookups for verified images. Of course, if your images has been verified based on the configured policy, you don't want to repeat that process again and again, and it's time consuming, right? With the caching in place, it'll save you some time when you deploy your applications or the workloads to the cluster. And this extension service also supports multi-tenancy, where you can configure different trust policies, like if you're following the specific naming convention, and for example, you enable your multi-tenancy using the namespace isolation, then you can configure the trust policy with the incoming namespace's name. And for workloads that are scheduled in different namespaces, this extension service will pick up different trust policy and use that to verify the specific set of images. And the high availability, right? So this, if you want to scale up this extension service, we also support that. The main service that, where the image verification happens doesn't require the leader election, where we also have this cert manager enabled in this extension service. And that is the only component which requires the leader election. Let's say when you configure multiple replicas for this extension service, the leader election is only required for the certificate management, but all your incoming requests will be distributed to running instances by the service, by the Kubernetes service, right? So all the replicas can serve your request at the given endpoint. All right, so those are the all the highlighted features that I want to briefly talk about. And with that in place, let me hand off to Vishal. He's gonna give us the live demonstration of all the mentioned features. For example, the image verification, attestation verification, image tag mutation, and beyond, right? So let me stop sharing, and then Vishal, please take it away.
Okay. Is my screen visible?
It's yes.
Okay, great. So hi, I'm Vishal, and I will be presenting a demo on the Kyverno Notation AWS plugin. So to install the plugin, what you can do is you can follow the steps in the plugin repository. There you will find an install section in the README. And once you have successfully installed the plugin, you will see the following resources in your Kyverno Notation AWS namespace. So here we have the pod, which is running the plugin, and a service which can be used to access the plugin through an API call. We also have the secrets and a lease for cert management, as well as a service account for authorization purposes. So once you have everything set up and running, then we will have to allow Kyverno to be able to access this plugin. And to do that, we have to set up a Kyverno cluster policy. So here we have a cluster policy called check images. And what this cluster policy does is that it checks for pod creation and update operation in the test notation namespace. And once it finds those, it sends an API call to the check images endpoint of the Kyverno Notation AWS service. it sends a post request with the following values, such as images, which is the Kyverno's images variable, which contains the image infos of the resource which is being admitted, and an optional argument called trust policy, which can be passed per request if you want to specify what trust policy to use for that exact request. We can also provide an argument called attestation, which we will talk about later. So once the plugin has received the request and has successfully verified it, it will give us a list of results, which can then be used to do JSON patches on the resource. So this is the policy we will be using. Let's apply this policy. So what happens when we try to create a pod in the test notation namespace is that the plugin will receive an API, an HTTP request, and then it will match the image infos received with a trust policy. So here we have the trust policy set up in the plugin. So what this trust policy has is that it has a trust store specified, which contains the information of the certificates that can be used to verify the signature. And it also has a trusted identity. So this is the identity of the AWS signer signing profile, which was used to sign the image. So if the image received was signed using a key that matches the certificate in the trust store, and it was signed using the Kyverno demo signing profile, then the verification will succeed. Otherwise, it will fail. So for this demo, we have two images. One of them is signed and one of them is unsigned. So let's start with the unsigned image. So let's inspect the unsigned image that we have. So when we pass this image to the notation inspect command, it says that there are no signatures associated with the image. So when we try to create a pod using this image, the verification should fail. So let's try that out. So here I'm trying to create a pod called test using the unsigned image. So when I do that, we receive an error saying that no signature was associated with this image, and we have to make sure that the artifact was signed properly. So it did not allow the pod creation. Now let's try it with an image that was signed. So here we have a signed image with the tag v1, and when we inspect it using the notation CLI, we see that it has a signature in it, which has the following signed attributes, which contains the AWS signer signing profile of type signing profile / Kyverno demo, which was also in our trust policy. So if we try to create a pod using this image, then the verification should succeed. So let me try to create a pod. So if we try to create a pod called test mutate using this image, the pod is created. And one thing, as I mentioned before, what the plugin also does is that it sends the digest of the image, which can then be used to create the pod. So if we get the information on the pod and to check what image it is using, you can see that we pass the image with digest and image with tag, and it is using the image with digest. As Shooting also mentioned, the advantage of using digest over tag is that it ensures image integrity and prevents tampering, as tags are mutable and digests are immutable. So this is what we get. This plugin allows us to update image tags with digest. One more thing we can do with the plugin is that we can also verify attestations in an image. So if we go back to the policy, there is another field that we can pass to the plugin. It is called attestation. So let me just uncomment this. So what this does here is that we are passing an image reference, which is a regular expression, which will be matched against all the image infos that are provided in the images variable. And once the image reference matches, it will check for an attestation of type sbom/example. Once it finds that sbom, what the plugin will do is it will verify that the um, attestation is signed using the same signature, as well as it matches this condition, which says that creation info dot license list version should be equal to 3.17. Otherwise, it will give an invalid license error. So now let's update this policy. So if we apply the policy here, the policy has been applied. Yep, the policy has been applied. And if we look at the signed image that we have, the image has an SBOM attached to it, which is also signed. So, and if we take a look at the SBOM that is attached, we can see that it has the license list version set to 3.17 inside of creation info. So when the plugin tries to verify this image, it should be able to see that the license list version matches, and it should allow us to create the pod. So let's just apply the policy again. And if we try to create a pod, using dry run, using the signed image, we can see that the pod is successfully created. Now let's see what will happen if I update the policy to use different license version. So it will try to check that the license version is 3.18 now that I have updated it. And if the license version is anything other than this, it will throw an error saying the license version is invalid. So let's write the policy and let's apply it. So we have applied the policy, and now if I try to create a pod using this policy, it gives us an error saying that the license version is invalid. That is because we changed the license version in the SBOM is actually 3.17, and we updated the policy to use 3.18. So it gives us the error message. One more thing you might have noticed is that any verification can take quite some time. It can take up to 10 seconds. Like in this case, it took 6 seconds. Sometimes it take 8 or 10 seconds. That is because we have to make several network calls to the ECR registry to get the descriptor or manifest or reference list, or in some cases, the entire SBOM, which can take quite some time. So to tackle that, we have caching involved in it. So once you have signed an image using the plugin once, what happens is that it goes to the cache, which is of type TTL. So the entry will expire after some time, and that time can be configured by the user using some flags. So the image is in the cache. So when we try to verify the image again, what happens is that the plugin will first check the cache for the entry, and if it finds it, it will use that entry instead of going to ECR to fetch all the information and do the verification again. So we previously verified the image with license version set to 3.17. So if I update the policy to use 3.17, and if I apply it, so I have applied the policy, and now let's just try to run the pod again. Like it is substantially faster than without using than when we making a network call. So in this case, it took long because my internet connection is bad, but yeah, it has like something to do with my internet. So it's taking 5 seconds, but if you are located closer to the server, then like in this case, it took much less actually. It can take up to 2 to 5 seconds to pull the image from the cache, and it will be much faster if you are located closer to the your cluster. Like I am in India and the cluster is in USA, so like that typical latency is also added. So if I just try one more time. Yeah, like in this case, it took 3 seconds. If you are going to make network calls, then it will take up to 8 to 10 seconds, which and the difference is substantially less. So caching helps in reducing the time taken. So yeah, these are the features that are provided by the Kyverno Notation AWS plugin. You can view data digest, you can verify attestations, you can use caching, you can use multi-tenancy, you can also like it allows us to use AWS Signer to do verification using Kyverno. So if you have any issues or doubts regarding this plugin, or you would want to suggest a new feature, feel free to reach us through the repository, which is at Nirmata/Kyverno Notation AWS, and we would love to talk with you further. So this is everything I had for the demo. So if you have any questions, you may ask now. Thank you.
Thanks, Vishal. Yes, Jim just joined the meeting. Not sure if you have anything to add to the plugin service, or I guess that's everything we have for this office hour. Let's see, we have, do we have any other things that we want to discuss?
No, nothing from me.
Okay, yeah, I think we have another reserved topic to talk about, the tracing. We recently added to Kyverno, but unfortunately, one our colleague won't be able to make it, so we'll reserve it for the next for the topic of the next meeting. Awesome. If there's no other questions, then thank you, everyone, and we'll see you in our next office hour for Kyverno. Thank you. See ya.
Thank you.
Bye-bye.